Alright, so this is the first week of the PySoy weekly Hangouts. We're going to talk about the state of the project and the beginning of the Google Coding. But first we're going to start off with a Gorse report someone made for Google Coding. So what were the main projects last year? I talked about the refactoring away from PyM and making everything new aged. What was there was one big thing I missed.
We'll do a lot of work with materials. We got all sorts of different stuff with bump mapping. The glow maps were re-added. We got checkered textures back. It was cube maps came back, and of course all of the bodies got enhanced. We have rounded edges on boxes now. The sphere got done, which it wasn't actually done before, and we had a general migration over to OpenGL ES.
Okay, so a lot of work in prettification of the objects. So that was definitely a big project. I remember working on a lot of the box rounding and stuff like that. That was a good amount of math.
All
right, so moving on to what I was talking about before you disconnect, I was talking about shaders. I said that shaders will help us to do physics calculations and move us away from ODE, and they will also just make everything better looking because OpenGL ES2 allows us to use shaders on the video card.
Well, it also lets us move into eventually into HTML5 clients. So right now, the strategy for the web client was a plugin, and increasingly, a lot of the browsers aren't even supporting plugins anymore. The OpenGL2 gets us very, very close to WebGL. WebGL is based on OpenGL2. It uses shaders for everything. And if we have the physics ported into using shaders, at that point we can implement most of the rest of the client in JavaScript. The really speed-intensive stuff is the physics. So.
So, what's his name? Samuel Kim has a lot of work to do there. He's already started. He's already done some monochrome visuals and done a bit of storage on it, but there's a lot of work there. It's almost a whole new graphics rendering engine. So for this year's GCI, the two main things that we're working on are the shaders that we just talked about, and also different platform support. The different platform support will allow us to use different loading modules to allow any windowing backend to run PySoy. So what that basically means is if you're on Windows, if you're on GNOME, or if you're on XFCE, or any desktop manager or Windows manager, you can just write a backend to connect that window manager's windowing process to PySoy. And that will allow us to move into whole new platforms. It will get us on Android, it will get us on the browser, it will get us on Windows, it will get us on everything. So what are the main challenges there?
Well, right now the plugin API is basically rewriting the front end stuff. It's pretty much there. I tried to go back into the GTK stuff, and I remember why I didn't like that. It tries to do too much, and now that we're in OpenGLES land, we don't have access to the nice plugins to GTK that do a lot of the stuff. I'm at this point refactoring it to not use GTK for the backend, just because it'll get us there faster. The other big thing is that plugins get currently PySoy acts as a client. You're either running, Raspberry Soy or Sweet Soy or whatever, or PySoy. PySoy is right now standalone because it is only for Linux because it has the X11 stuff built in. With the changeover, we should be able to launch PySoy or add PySoy to any client. So if you're running the Windows client, you can load PySoy up as part of the client and use it for game design or whatever, or just editing the game code while you're running it from within the client.
Yeah, and that's one of the main things that we need to work on before PySoy can be used by pretty much anyone. We need to make sure that it's readily available on every platform, because if you're just writing a game for Linux and you're using PySoy, which is built to do over the web and cloud interaction with it, then it's not going to be too useful. You aren't going to have too many users, and you're not going to have a good basis for people to work on. So if we can get it on so many different platforms and have just the clients running and a server running on one platform, which all clients can talk to, then that will just allow adoption on many platforms.
Well, there's also the issue that we have with GCI, in that every new student, almost every new student, as the first step to do anything is to install Linux.
Yeah.
And how many hours have we spent on that?
I mean, even just installing Ubuntu, which is arguably the easiest one to install, that takes a good 2 or 3 hours. And then once you set it up, you need to learn everything. It's completely different from Windows for most people. And that's not even talking about on a Mac, where it's much harder to even install Linux or use PySoy.
Yeah, Mac is going to be a really interesting client. So one of the things that we have on working right now is on Linux, you run Python. Python's the main thread. Then you open up this client, and this client runs this background thread to do all the rendering in a background thread. And that works on Linux, and it used to work on Windows, and it can work for Windows again very easily. The problem for Mac is that doesn't work. And this is the one more fun bugs we found that it turned out to be a OS level bug. Mac can't render from a background thread. Only the primary thread for a application can do anything with the windowing system or anything with OpenGL.
That seems like total restructure needed.
You want to do it with some kind of virtual machine?
What's that?
I don't know. I mean, I'm just wondering if we can run some kind of virtual machine, kind of.
Well, what we could do is make a IDE that embeds Python. The issue is that once Python's running in the primary thread, you can't move it to a background thread. We'd love to do a little do-si-do with the threads and make a background rendering thread the primary thread, because it really doesn't matter what thread's running what as far as PySoy is concerned. The issue is that if someone types in the word Python into a terminal to run Python, or tries to open a .py, it's going to run in Python and not in the IDE. The only workaround beside running it inside of a special IDE that we've been able to think of is having some sort of an IPC going on, and the rendering's happening in an entirely different process, which is completely doable, but that's going to be a pain in the ass.
That's a lot of work.
There's still a lot of work for the adoption, but hopefully this module system will help us to get at least on Android and Windows. That's a good first step. I mean, Mac users are probably used to not having too many games. But when we were talking about that, Anish just said he's still using Windows. So, Anish, how is that working for you? I know you can't talk, but just type in the chat and I'll relay your information.
Your microphone.
Oh, he's using he's using a virtual machine. So you aren't okay. So that's a different situation. I thought you were building on Windows. I tried to do that, and it's just hard to do, even with Cygwin or whatever you're using. So does anyone else have any other comments about the module system?
No.
Okay. Let's move on to what's happened so far this year. So in the first week of Google Coding, which was last week, we've had a lot of work done on documentation, and also the docs are auto-building when you're building PySoy, thanks to Daryl. So Daryl did a lot of work on documenting the new models we made last year, which weren't documented in the process, which probably was a stupid idea to write and not document. And also, one of the cool things is that instead of having to run a command every single time you build the docs, they're just built automatically and copied into your docs folder. So everything's automated like that.
You got the build bot?
Yeah, we have the build bot. I wrote a build bot on that just accepts a mercurial hook and will build everything, test for errors. Right now it's currently just building. It's not reporting errors, but I think I can extend that to have some kind of web page sent back to the builder, which will say which errors it caused, and that will help streamline the process.
All the commits have an email address in them, so you could also just send an HTML email.
There you go.
One of the things I like about the build bot is you can also, with a little bit of configuration on the server, we can also have the docs auto-build. So every time someone makes an update to the docs, it can update something like docs.pysoy.org to have web viewable documentation.
Yeah, and with Daryl's work, we can just do that very easily with just a copy command or something. One thing I was thinking of adding to that was we could actually just have when you commit something, you're sent a link back, which either says it worked and we're going to take your link in, or take your push in, or we could, if it fails, we could reject their push and just send them a link to which errors they had. What do you think about that?
It might work. I'm not sure how mercurial hooks work in that regard. I know we can't modify anything in the change set because of the distributed nature of it. With Subversion, we could. We could have it. It would actually be kind of an awesome update. The only thing I'd be worried about is I'd want to see all of the change sets. Right now, the BuildBot is building for every change set. If I'm working for 8 hours, and during those 8 hours I'm not pushing because my change sets are breaking compilation, but I don't want to put one big commit when I'm finished, I may have 8 commits sitting all at once. And the first 7 don't compile, but the 8th one makes them all compile. So before we did that, I'd want the BuildBot to wait until all of the changes are processed. And we may have to change the hook API for that. I know the hook gets all the change sets on the push, or should. It's a question of the API, because I think right now the API is issuing a web request to the build bot on every change set, not on the group of change sets.
I think it is on the group change sets, because I'm pretty sure the hook you have set up is on change group, not change set.
Okay.
But I'm not sure about that. That would need some testing.
Then we just have to make sure that the last change set after they've all been applied is the one that's building.
Yeah. Also, I mentioned earlier, but Samuel Kim has started his work on adding the shaders. That's definitely a big project. I'm kind of scared of getting into there, just trying to even look at shaders, so kudos to him for just getting that to build.
Yeah. We had an interesting problem with that last night. We thought it was a VAPI problem. In the VAPI files, Vola API files, is an interface between the language we use in C. And I made a change to the VAPI that I thought was going to be beautiful in the way that the buffers are being generated. You just give it a list of buffers that you want, and it gives the number of buffers as part of the automatic API to C, and everything should come back right. And it worked in what I tested it with, and then Samuel said, it doesn't work. As it turned out, what was happening was he was passing a temporary list of local variables. The list was being created just in the command call. What was happening is the EBO and VBO local variables were being put into this array as the initial values. Then the new values were overwriting those two values inside the list, and then the list was being deleted when the original two calls were not being updated at all. That was fun. That was 3 hours of debugging to figure out what was going on there.
So the VAPI can be a magical thing, but a lot of the times it just leads to some hard work. But once you get it working, though, it's pretty useful.
Yeah, the really fun part is when you get to build a whole new VAPI, like OpenGLAS 2. That was brand new, and we're going to have a lot of fun debugging that in the next couple weeks, because every turn there's going to be some new call that we haven't used before that's going to break something horribly in a way we can't easily debug.
It's too bad that the VAPI doesn't work with GDB as you'd expect it to.
Mm-hmm. Yeah, look at the source code lines that GDB is reporting in the built C files, and then trying to figure out how those built C files got built based on the VAPI and your source code.
Yeah. It's just manual debugging instead of automated debugging, which not really automated as GDB wouldn't really call that automation. So also Daryl Kremryov, I think that's how you pronounce his last name, but I'm not too good at pronouncing things, created some eye candy for us to show. So it's just a ball rotating on hinge joints. I almost think that kind of looks like a person.
He was trying to make it wave.
Wave.
It's not bad.
Yeah, not bad. It shows what you can do. It does have a good basis.
I think one of the big problems we have right now is we're so focused on the minutiae that we haven't actually built anything big with it yet.
Yeah.
We have all the pieces there. We know those pieces can build into something bigger, but everything in PySoy examples are these tiny, tiny little, like, here are 5 cubes. Here's a couple spheres. Here's 2 cubes connected with the joint. Here's something on a landscape. But nothing really beyond that.
No project, just game built. Even if it's just like a simple roguelike game or a maze game, I mean, it would help to show people what's happening.
Yeah. Hopefully we can, with the client changeover, one of the fun things is going to be the controllers have to be rebuilt. Because we have to have an API for that, and we can't rely on X11 stuff for the cross-platform client API. So
Anish just had a good idea. Mario's not too hard to build, the first level of it. We could have our Mario clone. That might not be a too bad of a
Yeah,
project.
just any kind of platformer would be great.
What'd you say?
Just any kind of platformer. Just
Although I'm not too sure how well 2D would work. I haven't.
Yeah, like a Mario 64 would be easier.
Mhm. It would still take a lot of effort to just build the scenes and stuff like that. But that is the hard part in game design. It's not really the coding; it's more of the visual and aspects part of that.
How about a 3D Pong?
3D Pong, 4-player Pong. Why not? All right.
Yeah, you have a ball on a planar scene, and you have a couple paddles on a slider joint.
Yeah,
Not a bad idea. That might be
an excellent idea.
That sounds like a Google Code and task for this week.
Okay.
Yeah.
All right. So, does anyone have anything else to talk about, or?
Did you already you put the Gorse for this weekend, or was that just 2012?
I put in the Gorse for 2012. Do we have one for this week?
Yeah, he uploaded it to the PySoy channel already.
15th to 22nd. There we go. It's not the topic of the podcast, but I think that really shows one of the strengths of distributed source things.
Yeah.
Just the ability to look back at all the commits and do something like that.
Yeah. It's pretty. Though I'm disappointed that January 1st on the 2012 one doesn't show me just having this giant like commit explosion during a 1 minute era that at exactly midnight January 1st every single source file got touched.
I remember that.
Yeah.
That what was it? The license update.
Yeah. This is going to be a fun one. 2014. We're using PEP 8 as a rough guide for source code formatting, which means 80 column limit. And the fun thing about that is the copyright string right now is almost at the limit. With the added comma 2014, it's going to break us into 2 lines. So the set command is going to be really interesting this year.
Okay, so I think that's the hangout for this week, unless anyone else has anything else to talk about.
I don't.
Okay, well, good hangout. See you guys next week, probably.
For hosting.
All right.
Okay.